Okay, so let's do practice quiz 6, question 1. So in this question we have a coin is flipped twice. So it's an experiment, a coin is flipped twice and a 6-sided die is rolled. So we're going to let H be heads, T be tails. So we have to find the following. A, the sample space. That's the set of all possible outcomes we could have. So we're going to label it as S and put a brace. Then we could have 2 heads and a 1. We could have 2 heads and a 2. We could have 2 heads and a 3. We could have 2 heads and a 4. We could have 2 heads and a 5. Oops. 2 heads and a 5. We could have 2 heads and a 6. I'll stop at 6 because the die has 6 sides. So then this guy, I can repeat and change it to maybe tails head now. So tails head, tails head, tails head, tails head 4, tails head 5, tails head 6. Then I could copy it again. I could get then heads, tails, heads, tails 2. Oops. Heads, tails 2. Heads, tails 3. Heads, tails 4. Heads, tails 5. Heads, tails 6. And then I get it all heads. Sorry, all tails. So I have 2 tails here then. Take away the heads. 2 tails here. Oops, on the outside. Get it inside there. Tail, tail, 2, tail, tail, 3, tail, tail 4, tail, tail 5, and lastly tail, tail 6. So let's close the brace at the end here. So if you count how many outcomes we have, you can see there's going to be 24 here if you count them all. So let's say the number in S is 24. Okay, let's keep going. So E1 now is the event of getting at least one head and rolling an even number. So an even number would be like 2, 4, 6, 8, and so forth. So let me take the sample space and look for the ones that satisfy that condition. So I'm just going to paste it here. So we need 1 head, so I guess the 2 tails at the end, you can eliminate all those possibilities. So take that away. And so all the rest have at least 1 head. So we need an even number. So the first one does not have an even number, so take it away. The next one does. Next one, the 3 is not even, so take it away. 4 is even, so the 5 is not even, take it away. 6 is even. Next one's 1, so take it away, it's odd. And 2 is good. The next one is 3, which is odd, take it away. And 4 is good, then take the 5 away. And next one, take the 1 away. Next one, take the 3 away, it's odd. take the 5 away, odd. So we're left with these guys. So note here, the number in E2, so if you count the number of things in E2 here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 is 9. So then the probability of E1 will be the number in E1 divided by the number in our sample space S. So E1's 9. We already mentioned above there the number in the sample space. If you count them all, there's 24. So 24 goes here. We can reduce this a bit as 3. 9 is 3 times 3. And 24 as 3 times 8. So reducing this, crossing the 3's off, will be 3 over 8. So there's 3 over 8 chance that event 1 will happen. So it's almost 50% chance. Okay, let's go on to event 2. Part C, which is talking about event 2. So event 2 is getting 2 tails and rolling a 1, 4, or 6. So let's take our sample space. So we need 2 tails, so pretty much we're just going to be left with all the tails. So take all these guys away. Okay, so within those we need a 1, 4, or 6. So this one has a 2 and a 3, take those away. It's a 4, take the 5 away. So therefore that's event 2. So note here, the number in event 2 is 3. So the probability of event 2 happening is equal the number in event 2 divided by number in S, the sample space. So E2 is 3, sample space is 24. So we could reduce this a bit because 24 you can write as 3 times 8, cross the 3's off, becomes 1/8. So there is 1/8 chance that event 2 will happen. Well, event 2 will happen 1/8 of the time. Okay, so probability of getting, so part C, probability of getting 1 head, 1 tail, and an odd number. Let's call that event 3. So we have 1 head, 1 tail, so you need a mixture. So you can't have all tails. So take those away. You can't, all heads. You can't have all tails either. You need a mixture of heads and tails. And then amongst those ones left, you need an odd number. And an odd number, yeah. So odd numbers 1, 3, 5, so forth. This is an even one. Take it away. This is an even one. Take it away. It's an even one. Take it away. It's an even one. Take it away. Even. Take it away. And even. Take it away. So we're left with those guys. So there's a slight twist in this one because we're not looking for the probability of E3. We're looking for the probability of E3 given that the first flip is a tail. So if you look amongst these, the ones that are the first flip a tail would be these first 3. So let's just, oops, go here. Let's highlight them. So those 3 in event 3 have a tail. The first flip is a tail, sorry. Let's go back up to the sample space and see how many have the first flip a tail. So we can see that it's actually these ones. Along with these ones. So it's pretty much half of them if you count them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 of them. So therefore how you write this is the probability of E3 given that. So to write given that, you write a vertical line. So given first flip equals tail. So you can see then it's going to be the number in E3 that has the first flip of tail, which is 3, divided by the number of things in S that have the first flip a tail, which we've already said was 12. So we can reduce this a bit. 12 you can write as 3 times 4. Cross the 3's off, and you get 1/4. Oops, 1/4. So we're done with question 1.